Okay, let's just dive right into this. If you're a support engineer or a front-end developer, you already know the absolute worst ticket you can possibly receive. It's the dreaded cannot reproduce bug. You know, the classic, well, it works on my machine badge of honor. You get the alert, you look at the issue, you click around your app for a bit, and everything works perfectly for you. But obviously, for the user, something completely broke. So in this explainer, we are going to transform you from a frustrated developer into a literal forensic investigator, using Sentry's breadcrumbs and event context. We're going to look at how to finally stop guessing what happened and start seeing exactly what led up to a crash. InspectGlit really hits the nail on the head here. They say every unhandled JavaScript error is a broken experience. Think about a checkout button silently failing, or a dashboard that loads halfway and then just freezes up. The brutal reality of this: users rarely actually file bug reports when this happens. They don't call support to help you out, they just leave. In fact, studies consistently show bounce rates jumping by up to 20% from just a single error. The vast majority of these front-end bugs are completely invisible because they're never reported by the users who actually run into them. So relying on user feedback to fix bugs? Yeah, that's a losing strategy. So let's say you catch the error in your monitoring tool. You've got the stack trace, great. But do you actually know the story? Think of an unhandled exception like a silent crime scene. A stack trace is really just the chalk outline. It tells you exactly where the code broke. Maybe it's a type error on line 247, but it gives you absolutely zero behavioral context. You have no clue what the user was actually doing. Did they frantically switch tabs? Did they double-click a submit button out of impatience? Did some random browser extension interfere? The stack trace simply doesn't know. And this right here is the major paradigm shift. Raw stack traces tell you where it broke, but breadcrumbs, they tell you why it broke. Look, with just a stack trace, you're basically just guessing at reproduction steps, kind of crossing your fingers and hoping you stumble onto the exact bizarre sequence of clicks that poor user made. Breadcrumbs totally flip the script by giving you the chronological narrative context of an error. They let you actually visualize the specific user interactions, the network cycles, and the state transitions that cause the whole system to come crashing down. So what exactly are they? Sentry defines breadcrumbs as a structured trail of events that live on scopes and are applied to error events to show what happened right before an issue. Under the hood, they are inherently categorical JSON records. And the absolute most critical behavioral rule of the whole breadcrumb system: they strictly maintain insertion order. That is huge. They aren't sorted by some absolute timestamp, they are sorted by the exact sequence they occurred, preserving the exact causality of events. Now you might be thinking, okay, do I have to go write 1,000 console log statements to get this magic trail? Thankfully, no way. Modern Sentry SDKs actually automatically record a massive amount of these critical clues right out of the box. They capture URL and UI navigation changes. They grab your console logs and format them automatically. They intercept outgoing HTTP requests and log the method, the URL, and the status code. They even capture UI events like button clicks or touch inputs, and system events like a low battery warning or a device orientation change. The whole shebang is captured automatically, silently building your timeline before the crash even happens. Section 1. Reading the forensic timeline. Decoding the clue board. So when you open up a Sentry project, Sentry actually translates all that raw data into these great visual forensic clues right on your timeline. It applies semantic conventions to the different breadcrumb types to make them super easy to read. For HTTP requests, they are color-coded, 2XX and 3XX successes are blue, 4XX client warnings are orange, and those critical 5XX server errors show up as red. Navigation types explicitly show the exact from and to routing paths. Query types will actually reveal the exact SQL statements or API calls, which backend teams absolutely love. And UI types use specific little icons to represent mouse clicks or touch events. So when you're looking at the Sentry dashboard, you aren't just reading dense text. You're reading a highly visual, intuitively color-coded map of your user's exact journey. Remember how we talked about insertion order? Preserving that insertion order guarantees that the final entry is the exact precursor to the crash. In modern distributed systems, relying on absolute clock precision across a bunch of different devices and microservices can be super unreliable. Timestamps might be slightly skewed, but because Sentry SDKs are strictly required to append breadcrumbs in the exact sequence they actually fired, you know for a fact that the causal sequence is perfectly accurate. That little blip right before the red error icon, that is exactly what triggered the failure. But what do you do if you have thousands of errors coming in at once? That brings us to Section 2. Filtering with context tags, narrowing the suspects. It's really important to understand the difference between unstructured data, like just a standard log message, and structured data. Context tags are indexed and searchable key value pairs. And because they're indexed, they become your primary mechanism for filtering and grouping issues in the UI. If breadcrumbs give you the chronological how of an incident, context tags give you the environmental what and the human who. You can tag a specific user type, a tenant ID, or even a payment plan tier, which instantly makes your error data incredibly searchable. So here is the exact three-step triage workflow a support engineer uses to just slice right through the noise. Step 1. Set the user identity. By using the Set User API with a unique ID or email, Sentry can group issues based on user impact. Step 2. Inject your custom business tags. For example, you can tag the environment as production or log the specific release version. Step 3. Use Sentry's Omni Search. This is a crazy powerful real-time search bar that matches strings across messages, tags, and data fields all at the same time. You just punch in the user's email and boom, you have completely isolated their exact browser environment and their specific crush trail. Let's move to Section 3, Case Study, the checkout failure. Let's put this forensic theory into practice. Walk through this chronological timeline with me. 2 minutes before the crash, the navigation breadcrumb clearly shows the cart page loaded. 45 seconds prior, a UI breadcrumb shows the user clicking right into the address entry field. And then there's the smoking gun. 2 seconds before the crash, an HTTP breadcrumb shows a failed post request to the checkout endpoint, maybe returning a 500 error. And finally, at 0 seconds, the JavaScript exception fires because the front end stupidly tried to read a success message that simply didn't exist. See? We didn't have to guess. We literally just watched the timeline unfold in front of us. And the best part, once you master reading these breadcrumbs, you unlock some really advanced forensic wins. You can reconstruct incredibly rare race conditions by seeing an HTTP request start, a user UI click happen right before it finishes, and then the resulting crash. You can seamlessly debug abandoned checkout flows. For instance, Sentry's session replay connected with breadcrumbs might show a user perfectly entering their details, but a custom breadcrumb reveals the shipping price dynamically increased by 300% right at the end, causing them to slam the tab shut in anger. That is a silent UX failure caught dead to rights, entirely through telemetry. So if you take only one thing away from this explainer today, make it this. Stop guessing, start watching. The most successful engineering and support organizations out there treat breadcrumbs not just as some neat byproduct of error capture, but as a primary engineering asset. Utilizing them completely transforms debugging from this reactive, frustrating, pull-your-hair-out guesswork into a highly precise forensic discovery of the truth. Which leaves me with the final question for you. Are you ready to stop guessing and start actually following your application's breadcrumb trails? The next time you see a cannot reproduce ticket drop into your queue, don't just try to replicate it blindly. Jump into your Sentry project, filter by that specific user, look at those little color-coded blips on their timeline, and just read the story your application is practically begging to tell you. Thanks for joining me for this explainer, and happy debugging.